Let's solve homework exercise number 1 from section 11.6. It states you are dealt 1 card from a 52 card deck. Find the probability you are not dealt a diamond. Okay, not a diamond. Now again, there are 52 cards in a deck of cards. There are 13 of each suit, so there are 13 diamonds. So then there are 52 minus 13, which would be 39 that are not diamonds. Okay, now you can do this one. So you know, now what happens is the probability then of not a diamond is 39, the 39 that are not a diamond out of 52, which reduces to 13 goes into 39 3 times, 13 goes into 52 4 times, so 3/4. Now you can also do some problems. You have to do probability of not a diamond is always 1 minus the probability of the event happening, which in this case is a diamond. Okay, so it would be 1 minus, there's 13 out of 52 diamonds, which then if we go up here, it would be 52 out of 52 minus 13 out of 52, which is equal to your 39 out of 52, which reduces to 3/4. So again, you can also use the fact that probability of a not of an event is always 1 minus the probability that the event occurs. Okay, in this case, it was probably easier just to do it directly because we know we had 39 cards and are not diamonds. Either case, we get the answer 3/4 in reduced form. All right, the graph shows the probability of a cardiovascular disease by age and gender. Use the graph to find the probability that a randomly selected man between the ages of 45 and 54 has cardiovascular disease. So let's go ahead and hit the magnifying glass to blow it up. Okay, 45 to 54, a man has cardiovascular disease. So 45 to 54 is this age range right here. Blue is min is in blue. So we can see blue right here, the tip of it is a little bit below 0.4. 0.3 is here, so this would be 0.35. So it looks like a little bit more than halfway between 0.35 and 0.4. So I would say something like 0.38 or maybe possibly 0.37. Usually if you just put in a number close, you'll get it correct because they have a number range there. So let's go ahead and put in 0.38 and see if we get it correct. We should. Let's close that. Yeah, we do get it correct. Now, use the graph to estimate the probability a randomly selected man between the ages of 45 and 54 does not have cardiovascular disease. Well, probability of no disease is 1 minus the probability that they do have the disease, cardiovascular, right, in this case. So 1 minus the probability 45 to 54 has cardiovascular disease. We just did in the first part, which was 0.38. So 1 minus 0.38, you can do it on your calculator, is 0.62, okay? So that would be the probability that they do not have cardiovascular disease. It's always 1 minus the probability. The probability of not the event occurring is 1 minus the probability of the event occurring. So in this case, the probability of no cardiovascular disease is 1 minus the probability that they do have cardiovascular disease in that age group 45 to 54. So it's 1 minus 0.38, which gives us 0.62. All right, the table shows the distribution of a random sample of 3,050 moviegoers ages 12 to 74. If the moviegoer is randomly selected from this population, find the probability in simplified fraction that the moviegoer is not 45 to 64. So what we want to do is we don't want 45 to 64. So we want either this age group, this number, or this number, right? Now again, you can add up the 680, 860, and the 550 to get the number in the 12 to 24, 25 to 44, and 65 to 74. But also, you don't want 45 to 64. And if you know the total is 3,050, then you can just subtract the 960 in the age group 45 to 64, and that will be the same thing as if you add these three, right? You'll be left with the 680, 860, and 550. So we can do it a little bit shorter that way. Then we're going to get that number, and then we're going to go ahead and divide that number by the total to get the probability, which is 3,050, right? So again, so to do it, we could simply take the, to not get the 45 to 64 age group, so we can take the total, which is 3,050 minus, in the 45 to 64 age group, 960, and then that leaves us with the other three, the 680, 860, and 550, which would have to add up to 2,090. And now to get the probability, we divide by the total in the sample, which was given to be 3,050, and we get the decimal, but we want a fraction, so definitely use your math key and then hit enter twice, and very nicely the calculator gives you the fraction in reduced form, 209 over 305. So definitely use your fraction key on your calculator because it gives it to you in reduced form, okay? Makes it a lot easier. Again, if we would just add it up, the 680 plus the 860 plus the 550 in the other three groups, there's our 2,090. So there's the other way of doing the problem. All right. Let's look at number 4. The table shows a distribution of, by age of a random sample of this time 3,320 moviegoers, ages 12 to 24. Find the probability expressed in simplified fraction that the moviegoer's age is less than 65. So 65 or younger, right? 65 or younger, so we don't want this age group, right? 65 or younger would be these 12 to 24, 25 to 44, and 45 to 64. So we would add up these, or alternatively, we're just going to get rid of the 330, right? So if there's 3,320, subtract 330, and that gives us what's left over, which would be the 1120 plus 1060 plus 810, okay? Because we know there's 3,320 altogether. And then we're going to divide by the total of 3,320 to get the probability. So again, we could do it a little bit faster if we simply take the total, 3,320 minus the 65 to 74, because we want the people less than 65. So we take away the oldest age group. There's 330. We're left with 2,990. To get the probability, we divide by 3,320, get our decimal, and then to get a fraction, remember, hit the math key, and then fractions highlighted, so hit enter once, hit enter twice, and it automatically gives the answer as a reduced fraction. So that's very nice, 299 over 332. So definitely use your fraction key. Okay. You randomly select one card from a 52 card deck. Find the probability of selecting a 2 or an 8. Okay, the probability of a 2 or 8. So when you get two probabilities, there's nothing, they're mutually exclusive, nothing's in common, then you just take the probability of a 2 and the probability of 8 and add them together. So probability of a 2, we know there's 4 2s, 2 of hearts, 2 of diamonds, 2 of clubs, 2 of spades. Same way with the 8, right? There's 4 8s, clubs, 8 of clubs, spades, diamonds, and hearts. So we add them together, we get 8 out of 52, which if we reduce, 4 goes into 8 twice, 4 goes into 52 13 times. So our reduced answer is 2 over 13, or put it in your calculator and hit enter and and get the fraction, and you'll get it in reduced form. Okay, so again, 8 divided by 52, And actually, you can just go to math and go ahead and just hit enter twice. You don't even need to get the decimal. And there's your fraction in reduced form, 2 over 13. All right, number 6. We've got randomly selected card, 52 cards, a black 9, probability of a black 9 or a black 3. Okay, again, it's the probability of a black 9 plus the probability of a black 3. No overlap, so we just add them. So a black 9 is the black of clubs or the black of spades. Black 9 of spades or the 9 of clubs, 2 cards. Black 3 would be the 3 of clubs or the 3 of spades, 2 cards again. So 2 plus 52 plus 2 out of 52 is 4 out of 52. 4 goes into 4 once, 4 goes into 52 13 times. So reduced form would be 1 over 13. Okay? So we'll go ahead and put that in. All right, we got it. We are going to stop this session here. This is your math teacher, Dr. Swears. I hope you found this video helpful. If you have more questions, if you need more help, send me an email through the inbox using the Canvas course at the portal. Again, this is your math teacher, Dr. Swears. Thank you for watching this video.